This video is the first of a series intended to explain the fundamentals and use of root cause analysis in food safety management, specifically the HACCP system. To start, let's do a rapid overview of cause and effect relationships and how creating drawings makes their analysis easier. The three most basic elements of cause and effect relationships are the cause, the effect, and the direction of the relation. A variety of causal diagrams can be drawn using these elements. Causal thinking has a long history that continues to be reviewed by modern scientists like Judea Pearl and his Book of Why. Causal inference is used in machine learning and artificial intelligence. The visual representation of causal relationships has been found helpful by scientists to understand how additional factors could affect experiments to establish the effect of treatments on outcomes. The charts used by scientists are called directed acyclic graphs or DAGs. Their use ranges from medicine to economics and computer science. In a food-related experiment, it could be visualized that a heat treatment applied to a food material could be affected by the operator, its previous knowledge and cultural background. Causal relations are also illustrated using causal loops. Sustainability professionals use them to understand systems because it helps to visualize the cyclical nature of the environment. Causal chains can be endless. This concept is also reviewed in the third video of this series. Causal loops are related to feedback loops, a concept used in control systems. For example, the cooking activity can be analyzed by understanding how an operator turns the heat on and off as it cooks. Causal relations are explained with scientific experiments to provide evidence of a claim. Most scientists use the phrase correlation does not imply causation to imply that more is needed. The criteria developed by Bradford Hill include correlation as one condition to establish that a relation is causal. These criteria were originally proposed to be used in epidemiology. Three of these criteria are of the most practical and universal use. They include correlation, time order, and specificity. Some scientists prefer to use the criteria John Stuart Mill proposed a few years before. They are the same as the three selected from Bradford Hill's list. Other investigators in the social sciences prefer to add the criteria of an explanatory causal mechanism and context. Fundamentals of cause and effect are also used in the theory of constraints, or TOC, to solve management problems. A physicist advanced the fundamentals of TOC. TOC practitioners use graphics called trees to visualize the idea that effects are derived from causes that originated from other causes. The various types of trees use one of two types of logic: necessity or sufficiency. Necessity is explained with the words "in order to, we must," and sufficiency with "if, then." In the TOC portfolio, the only tree that utilizes the term root causes is the current reality tree. This type of tree is used to identify the things that need to be changed in a system. The terms conditions and effects are used interchangeably in a current reality tree. TOC trees also use the term injections as a synonym for actions. This observation will be helpful in the following video, where other root cause analysis trees that use conditions and actions to describe causes are compared. TOC practitioners use a set of criteria called categories of legitimate reservation to review the observations made in the trees after they are created. Writing clear statements is the easiest. Conclusions about cause and effect relationships include: visualizing them is key. There will be new uses in the future. They are not always linear and not simply established with a correlation. I hope you acquired some valuable information for your conversation about causation with scientists and managers. Thank you for watching this video. The author will be happy to collaborate on projects related to these ideas.